Welcome to today's video. Today we're going to be focusing on simplifying expressions by using the law of exponents rules. We're going to focus on multiplying, dividing, and power to a power. Again, we're going to show that mastery in class by scoring at least an 80% on our exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a separate sheet of paper so you can write it on there. That way when you come to class, we can give you a fresh one, but you'll have the notes with you. Now, we're starting out with the basics today for the exponent rules. When we talk about exponents, we're going to start by talking about monomials. Monomial is an algebraic expression that has only one term. That prefix mono means there's only one. There's no addition or subtraction in the problem. There can be division and there can be multiplication because you are just dividing once or multiplying. Now, when we talk about multiplying with exponents, we're going to talk about expanding the form to really make sure that we understand what we're doing. So if we look at our first example, 2 to the third, well that means I have 2 times 2 times 2. It's 2 to the third power, so we'll make sure you're multiplying. It's not 2 times 3, we're not adding 2, it's 2 to that third power. Our second, 2 to the fifth, that means we need to have 5 2's. Well, if I count all my 2's in total, that means there's 8 2's. However, we don't want to say we're doing 2 plus 2 and say 2 times 8. In this case, it's going to become 2 to the 8th power. So, if we look at our second one, we have 4 to the 5th. That means I'm going to have 4 times 4 times 4 times 4 times 4. I need it 5 times. My exponent for the second one is 4 to the second power. So that means I need it 2 times. That exponent just tells me how many times I'm multiplying. So now if I count, there are 7 in total. So that's going to be my exponent. Well, they're all a 4. So my base of my exponent is going to be a 4. So my answer would be 4 to the 7th power. If we look at the next one, a to the second, we have 2 a's for a to the second. We then have a to the 7th, which means we have 7 a's, giving us a total of a to the 9th. For our next one, we have m to the 3rd. That means I need 3 different m's. Then I'm going to do m to the 4th power. Again, just like numbers, that means there's 4 of them. So 1, 2, 3, 4, and I'm still multiplying all of them. If I add it all together, that means there's 7 m's in total. So my exponent is 7, and my base is m, because we're always multiplying that m times m times m. Now, we're going to take 2 monomials and multiply them. Well, if I look, I have 5m squared n to the third times 2m to the fourth n to the second. Again, we're going to expand it out, but we can't leave the coefficients. So that means for my first term, I have 5 times 2 m's and 3 n's, and we're going to write it all out. My second term, we have 2 times 4 m's and times 2 n's, so we write it all out. Now, from here, it's just like when we did simplifying expressions. We want to combine like terms. Well, we're only combining and counting the like variables. Well, 5 times 2 is 10, so my coefficient stays 10 now. And I'm going to count my m's. Well, I have 2 here, and I have 4 here, giving me m to the 6th. I have 3 n's here and 2 n's here. That gives me n to the 5. They're different variables, so we cannot combine them together. So if we look at the bottom one, I'm going to expand it out. I have 4x to the 8th, y to the 3rd, so that's 4 times 8x's, 3, 4, 5, 6, 7, 8, and 3 y's. And I'm going to run out of room, so I'm going to write it underneath. We are now multiplying times 6, and I have 5x's. Now, if we look, y doesn't have an exponent. Well, what I'm going to do, just like if there was a coefficient, we didn't know what that was, we're going to add a 1 there. We want to make sure we add that 1 to symbolize that there is 1x we're multiplying by. Now, I want to make sure I combine like terms, but in this case, we're multiplying. 4 times 6 gives me 24. If I count my x's, I have 8 x's in the first one, and I have 5 x's in the bottom. That means I have 13 x's for my exponent, and now I have 3 y's, and I still have that y there, so that is y to the 4th power. Now, for the product rule, to multiply when two bases are the same, meaning the exponents can be different, but I need the variables to be the same, you write the base and you add the exponents. But this is why it works. We can expand it and see why that works. Now, if we look at dividing, again, we still want to focus on that expanded form because we want to make sure we understand what the rules are asking. If it is 2 to the 5th power, that means I need 5 2's, just like the first time. That doesn't change. In the bottom, I have 2 to the 3rd, so I still need 3 2's. Again, just like last time when we expanded, it does not change. Now, here's the thing. If I take 2 divided by 2, 2 divided by 2, and 2 divided by 2, all 3 of those are going to go to 1. So that means I have 2 to the 2nd power left on top because there are 2 of them. So if we look at our next example, we have 4 to the 5th power. That means on top I need 4 times 4 times 4 times 4 times 4. 4 5 times. Well, on the bottom I have 4 to the 1st. So that is all over just 1 4. Now, if I do what I did above, and I'm going to circle my groups that make 1, well, 4 divided by 4 gives me 1, so those disappear. I'm left with a base of 4, and I have 4 of them left. So my exponent becomes a 4. Again, we're going to do the same thing with variables. If I have m to the 9th power, that means I have 9 m's. If I have m to the 3rd power, I have 3 m's. If I circle my groups, well, that makes 1, that makes 1, and that makes 1. That leaves me with 6 m's left. Well, my bases are all the same, so m is my base and 6 is my exponent. If I write out the next one, I have 7 n's. So n times n, and we're going to do that 7 times. 5, 6, 7. For my denominator, I have n to the 4th. So that means I need n 4 times. From here, I'm going to circle my groups that make 0. Or excuse me, that make 1, because when n divided by n is 1, that means I have 3 n's left, and we're multiplying, so that is n to the 3rd power. Now, when we have bigger monomials, you still want to expand it the same way. So in this case, my numerator, I have 6x squared y. Well, I'm going to do 6 times x times y times y times y times y. The denominator, we're going to do the same thing. We're still expanding it out. It's 3. And remind yourself, put that 1 with the x, that there is still 1x there. We can't just get rid of it. Well, if I look, those make a 1, those make a 1, those make a 1, and those make a 1. So now we're going to have to do the division. Well, 6 divided by 3 gives me 2. I have 1x left and 1y left. So I have 2xy. There's 1 left. You don't have to put the exponent 1, but if you put it there to remind yourself, that's fine. Now, for the last one, we have 10a to the 4th x to the 9th. So 10, we have 4 a's. Yeah, and I'm going to run out of room, so I'm going to 10 times 1, 2, 3, 4. And now I have 9 x's, so I need 9 x's multiplied together. 4, 5, 6, 7, 8, and 9. Now, for my denominator, I have 2a, and I'm going to add that 1 there to remind myself, and x to the 7. So I'm going to do 2 times a, and now I need 7 x's. 1, 2, 3, 4, 5, 6, 7. Now I'm going to go through and circle what makes a group of 1. Well, a divided by a does. And I'm going to start kind of in the middle just because of the way I have it spaced out. Now I'm going to circle all my x's that can group together. So now, if I look, we're going to do our division. Well, 10 divided by 2 is 5. I have 3 a's left, so my base is a, my exponent is 3, and I have 2 x's left, so my base is x, and my exponent is 2. From here, for our quotient rule, when two bases are the same, you keep the base and you subtract your exponent. But this is why it works in expanded form. The last rule for today that we're going to focus on is a power to a power. Now, we already know that a power means that's how many groups we're multiplying together. So if I have a power to a power, this first one is saying 2 to the third 4 times. So I need 2 to the 3rd 4 times. So that means I need multiple groups. Well, if I now count, my bases are all 2. There are 12 of them, so now my exponent becomes 2. In this case, my base is 4 to the 5th, so that means I need 4 5 times, and I need 2 groups. So now I need another group of 4 to the 5th. Well, if I look, all my bases are still 4, but now if I count them, there are 10 of them. The same thing's going to go for variables. If it's m to the second 3 times, well, I have m times m, and I have 3 groups of them. All my bases are the same, and there's 6, so now my new exponent is m to the 6th. If we look at x to the third 5 times, that means I need groups of 3 x's being multiplied 5 times. So it's going to become x times x times x. Well, that's one group, but I need to do that 5 times. 2, 3, 4, 5. If we look, all my bases that I'm multiplying are all the same, so my base is still going to say x, but if I count them, this time there are 15. So my exponent is x to the 15th power. The same thing goes when we talk and we mix variables and coefficients. We're still taking that whole group, so 3b to the first power, y to the 4th, and we need 2 groups of that. Well, now we have to go by each term. 3 times 3 gives me 9. I have 2 b's, so that gives me b to the second, and I have 8 y's. So that means my base is y and my exponent's 8. So for this last one, this is telling me I have that monomial and I need 3 groups of it. So I have 2 times k 3 times x 4 times. Now we're going to do the same thing 2 more times. 2 times 3k's times x 4 times. Hopefully you wrote smaller than I did. I'm going to have to write my last set down at the bottom. Now we want to combine what's the same. Well, 2 times 2 is 4, times 2 again is 8. If I look at my k's, I have 3 in the first group, 3 in the second group, and 3 in the third group. Well, that gives me 9k's, so I have 9 with an k with an exponent of 9. And then if I look at my x's, I have 4 x's there, 4 x's there, and 4 x's there, giving me a total of 12 x's. So it becomes x to the 12th power. So our power rule, when you want to raise a power to another power, so when you have an exponent to another exponent, you write your base and you multiply your exponents. And it's important that your base stays what it is. If it's 2 to the 4th, you need to keep it as 2. If it's a variable, you keep the variable. Just make sure that if there's 2 separate terms, a variable and a coefficient, you make sure you multiply those coefficients together. Hopefully, showing you the expanded form will help you better understand these rules and give you a better understanding of them. Please come to class tomorrow with any questions you may have and your notes. I look forward to seeing you then.